This video is to demonstrate doing a separate excitation on a 20 RESA. The reason for doing a separate excitation is if you're running a generator, you're not developing desired output voltage, you're getting a locked rotor fault. You need to determine if it's the alternator is an issue or do you have a voltage regulator in the controller issue. To do that, to do a separate excitation, what you're going to take is a harness that you have your battery connections, a positive and negative, and you have two positive and negative connectors you connect up to your brush block. You're supplying the rotor with battery voltage. You disconnect the harness coming off the voltage regulator out of the controller, and you hook up the harness. And in the harness, you also have a connection where you take a multimeter set up for DC amps, and you hook it up in series in your harness to measure the current flow to the rotor. In the manual, under specifications in section 1, it gives you parameters for your output voltage using the 12-volt battery and what your output voltage should be. We're going to be measuring both our 11 and 44, which is our voltage sensing circuit, and 55 and 66, which is our power boost circuit for the voltage. And we're going to compare that to what the service manual, section 1 under alternator specifications, provides us for parameters using a 12-volt battery providing separate excitation. So what we're looking for is we want to make sure that the current that's going to the rotor in that circuit maintains an equal and steady current, approximately 1.8 to 2 amps, while it's running. Then we want to see what our voltages are on our 55 and 66, and then we'll compare them to what it gives us in the service manual. On the 20 RESA, when we use the 12 volts, we're only going to develop approximately 177 to 178 volts output. With this controller, our under voltage is around 206, so this will shut down in about 10 seconds while we're doing our separate excitation with an under voltage fault. So right now what we're going to do is we're going to connect our harness, connect our meter up with the amperage, and we'll look at and see what our amperage draw is with the rotor hooked up to the battery and our amp meter hooked up into our harness with it statically sitting there, and we can verify we have a good circuit through our rotor before we run it. So right now we have the harness, and now we're going to hook up to the brush block. So on the brush block right now, you'll see we got a FP and FN that is coming from the controller P2 connector that is supplying us our voltage regulation for our field. So the voltage comes through, goes through the brushes to the slip rings, goes through the rotor and back, magnetizing the rotor, giving us a magnetic flux to cut our stator windings to give us our AC output. So what we're going to do is we're going to hook these leads, move them out of the way. I'm going to take one end of my harness, I'm going to hook up to the brush block. So I'm hooking up a positive and I'm hooking up a negative on my harness. So now I have it hooked up to the brushes, and I'm substituting the voltage regulator in the controller for the battery. And we're going to test the alternator operation and the rotor. The next step I'm going to go over is I'm going to hook up my meter that's set up for amperage and put that in series on the negative circuit of my separate excitation to measure the current flow to this rotor. So now we're going to hook up our meter. The meter's set up for amps DC. I had to move my meter lead from the common connection over to the amperage connection on the meter. I have my two meter leads. I'm hooking it up into my harness so it comes off the negative, comes up, it's going to go in this meter lead. I hooked up here. It's going to go down in through the rotor and come back through this meter lead. So what this does is it puts it in the meter in series with the negative, so it's going to read the current flow through the rotor. So now what I'm going to do is I'm going to take my battery leads, I'm going to hook up my positive, then I'll hook up my negative. You see a little arc there, and here I'm reading 1.7 amps now, or 1.8 amps. So that's my complete circuit. So the voltage is going in through the meter, down through the rotor, back, and back to the battery. So I have 1.8 amps of flow through the rotor right now with a 12-volt battery. So now what we're going to do is we're going to start the generator, and we're going to monitor our amperage to the rotor. That should stay stable, shouldn't change. If that amperage drops off to 0, we have a running open. If it starts climbing and going high, we have a running short, and we have a rotor issue that we'd have to investigate and possibly change the rotor. voltage. So you saw we had 117 and we had 177 and approximately 1.7 amps. So our amperage is good. It didn't vary. It dropped to 0.1, which is minimal. And we're back to 1.8. So that all checked out. Now we're going to get the service manual out. We're going to compare those values to what it calls for in the specifications. So now what we're going to do, we did our recordings, we have our meter readings, so we're going to go to the service manual for 1420 RES, RESAL, TP6805. You go to the index, and on the index, section 1 of specifications, on section 1.5 it says alternator specifications on page 14. So we go to page 14, we go here, it gives us our current, our ohms resistance for our rotor on a 20 is 5.6. If you take that and you divide it into your battery voltage, which is approximately 12 volts, you're going to have around 2 amp draw. We had 1.7. 0.3 amps were within limits. Down here it shows you stator output voltage with separate excitation voltage using a 12 volt battery. So we did it with a 12 volt battery, and right here they're giving us on leads 1 and 2, 3 and 4 is 88 volts. We're reading across 11 and 44, and that here shows us 11 and 44 is 176. We had a 177. That's good. On 55 and 66, our power boost winding, it's saying 117, and we had right around 117, 118. So that all checks out. So that alternator, with these specifications, with that separate excitation, there is not an issue. So if we had an output issue, it would be in the voltage regulator in the controller. With that, you'd have to go to the wiring diagram and measure and ohm out your FN and FP leads going back from the P2 connector on the back of your RDC2 controller to your brush block, and the wiring there, and ohm that all out. And check your parameters and settings in the controller. If they all check out, it possibly could be a controller voltage regulator issue. Thank you and have a nice day.